Welcome to AI Podcast. Today we're digging into a new survey at EMNLP called LLM Agents for Education, led by Zhendong with Chingsong Wen and colleagues.
I saw that title and thought, agents in classrooms, that sounds both exciting and a little scary. What's the quick takeaway?
The punchline is simple. The field is converging on two big use cases for agentic LLMs in education. One bucket helps teachers with things like classroom simulations, feedback on student work, and curriculum design. The other bucket supports students directly with adaptive learning, knowledge tracing, and error detection or correction. And the authors map which agent skills matter most for each job: memory, tool use, planning, personalization, explainability, and sometimes multi-agent teamwork. Then they call out the hard parts: privacy and fairness, hallucinations and over-reliance, and actually plugging these systems into real schools.
So it's less a new algorithm and more a field guide.
Exactly, a map of the territory plus a list of potholes.
Who's behind it and where do they sit?
The team spans Squirrel AI Learning, Fudan University, HKUST in Guangzhou, Tsinghua University, and the University of Illinois Chicago. It's published in Findings of EMNLP 2025.
Got it. Let's rewind a bit. What problem are they trying to solve that earlier educational AI didn't crack?
Earlier waves, think knowledge tracing and cognitive diagnosis, were great at analyzing what students seemed to know, but they struggled with rich context and interactive help. It's like having a spreadsheet of quiz scores without a tutor who can talk, remember your quirks, and plan a path for you. LLM agents promise to fill that gap by combining long-term memory, tool use, and planning.
When you say memory here, what does that look like in practice?
Picture an agent that keeps a safe, scoped notebook about you: what you've mastered, what frustrates you, how you prefer explanations. Short-term notes for the ongoing dialogue, longer-term notes for your overall progress. Managed well, that's the difference between a one-off chatbot and something that actually teaches.
And tool use is like a Swiss Army knife.
Right. Instead of guessing a calculation, the agent calls a calculator. Instead of inventing facts, it retrieves from vetted sources or a school database. Planning is the air traffic controller, breaking a learning goal into steps and sequencing them sensibly.
Okay, walk me through the two buckets, starting with teacher assistants. What's classroom simulation?
Imagine you're testing Monday's lesson on Newton's laws. A simulation agent plays the roles of students with different backgrounds and attitudes. You nudge the discussion, it responds like a small class, and you see where explanations fall apart. The authors argue this needs memory, planning, and ideally a team of agents, so you can have, say, a teacher agent, a skeptic student, and a facilitator that keeps things on track.
That's fun. And feedback?
Feedback comment generation is about producing specific constructive comments on essays, code, or math steps. Here, planning and explainability matter. The agent needs to structure its critique and show its work in a way a student can follow.
Curriculum design next, right?
Yep. Think of it as making a playlist for a course. The agent pulls resources, sequences them, adapts for time or level, and justifies why it chose each piece. Tool use plus planning plus personalization. The justification bit is crucial. Teachers need to see the reasoning to trust it.
Now the student side. What exactly is knowledge tracing? I hear that term a lot.
It's the running estimate of what a learner currently understands. Traditional models infer that from right or wrong answers. Agentic approaches can also reason through a conversation, asking probing questions, explaining decisions, and updating the learner model as they talk. Some setups even split the roles across multiple agents, like an administrator, a judge, and a critic, to make the assessment more reliable.
And adaptive learning?
That's where the agent becomes a gentle coach. It looks at your recent attempts, suggests the next mini-task, adjusts the pacing, and changes explanations when you hit a wall. You can think of memory plus personalization as the engine, with planning steering the route.
Error detection and correction sounds straightforward, but what's new there?
Two things. First, Agents diagnose misunderstandings in writing, programming, or math step by step and guide you to fix them rather than just handing over the solution. Second, they're starting to handle multimodal drafts, like reading a photo of your handwritten math and then giving targeted feedback.
Do the authors run experiments, or is this a literature sweep?
It's a survey. They review recent work and they also compile resources, datasets, and benchmarks so people can actually test systems consistently. They even include a domain appendix that tours agents in science learning, language learning, and professional training.
Sounds comprehensive, but let me poke a little. What do they say about the rough edges?
3 big ones. First, privacy, bias, and fairness. Educational agents process sensitive data, and if you're not careful, models can amplify disparities. They recommend things like machine unlearning to forget sensitive data on demand, automated fairness checks for outputs, and culturally aware designs, so explanations make sense across contexts.
And the second?
Hallucination and over-reliance. Even confident wrong answers can sneak through. The paper pushes self-checking agents that reflect on their outputs and teacher-in-the-loop workflows so educators can correct and curate. They also argue for embedding pedagogical constraints, basically align the agent with good teaching practices so it can't shortcut learning.
And the third challenge is integration?
Exactly. Schools run on people and processes, not just APIs. The authors say we need structured frameworks for where agents sit in project-based learning, assessment, and day-to-day classroom tools. Plus, we should measure more than task accuracy. Look at learning gains, engagement, and trust over time.
You mentioned multi-agent teams earlier. Why not just one really smart model?
Teams add specialization. A planner agent sets the path. A critic checks reasoning. A coach shapes the message for the student. It's like having a department meeting in miniature. Fewer blind spots, clearer roles. Of course, that increases orchestration complexity, which is why their taxonomy is helpful. It tells you which roles to bother with for a given task.
If I'm a district leader listening to this, where would I pilot first?
2 safe, high-leverage spots. Feedback assistants that draft comments for teachers to review and edit. Saves time, keeps humans in control. And adaptive practice for students in a single topic, tightly scoped, with clear guardrails and opt-in data policies.
What about evaluation? We've both seen projects fall apart because everyone measures something different.
The survey leans hard on that. They index available datasets, but also encourage unified suites per task with cross-task metrics. For example, not just whether an agent's advice is correct, but whether its explanation improves the next attempt. And they call for public leaderboards that reward reliability, not just clever prompts.
Let's hit limitations of the survey itself. What should listeners keep in mind?
It's a fast-moving space. The authors admit they could miss the very latest work. And because it's a narrative survey, they don't run head-to-head replications or compute effect sizes. The capability to task mapping is principled, but it's still a judgment call.
Right, so it's a compass, not a stopwatch. Any concrete future directions that stood out?
A few. Privacy-first design, including unlearning, self-verifying tutors and teacher-in-the-loop review, better multimodal agents that can handle text, diagrams, code, and handwriting without defaulting to one modality. And most importantly, in-the-wild classroom studies that track learning gains and equity, not just benchmark scores.
If you had to explain the contribution in a coffee shop analogy, how would you put it?
Think of the field as a bustling market. There were stalls everywhere, tutors here, graders there, simulators over there, and lots of shouting. This paper puts up a big map at the entrance. It shows where each stall belongs, which tools the vendors need, and where the health and safety rules are posted.
That's tidy. Before we wrap, give me a quick example scenario that ties it together.
Sure. A high school biology teacher wants to revamp a 4-week unit. A curriculum agent drafts a sequence with readings and labs and explains why it picked each item. A feedback agent helps mark lab reports with transparent comments the teacher edits in minutes, not an hour. For students who struggle with graphs, an adaptive agent gives a short practice path, checks understanding, and nudges them forward. Behind the scenes, a critic agent double-checks factual claims, and all of it is logged for the teacher to supervise. That's the ecosystem the paper is pointing to.
And the guardrails?
Consent for data use, a clear policy for what the agent remembers, bias checks on generated examples, and a standing rule that human judgment is final.
Nice. Okay, final takeaway?
The field now has a shared vocabulary and a sensible division of labor for educational agents. The big wins will come not from raw model tricks, but from privacy-first design, reliability by default, and careful integration into real classrooms with solid evaluation.
Right, build systems teachers can trust and students can actually learn from. That's LLM Agents for Education from Chu Wen and team in Findings of EMNLP. If you pilot any of this in your school, we'd love to hear how it goes.
Thanks for listening to AI Podcast. Until next time.